Now this unit that we're learning about first is on linear equations, but before we jump into linear equations, we're going to talk about linear expressions, which are like the baby form of linear equations. Okay, so an expression, that's your first vocabulary word. This might be a good thing to have written down in your notes. An expression is a mathematical phrase that consists of numbers, variables, and arithmetic operations. Now, arithmetic operations are just adding, subtracting, multiplying, and dividing. So if we see those symbols, then those are okay in expressions. So here are some examples of some expressions. Notice they have numbers, they have variables, they have arithmetic operations. There's even a multiplying right there. Notice the one thing that they don't have is an equal sign. Equal signs are not in expressions. Okay, so notice they're just kind of baby forms of equations. Okay, now in order to model these expressions, and later on we'll be modeling equations, we're going to be using modeling tiles. Now, maybe in 7th grade you use something to model equations with. In 8th grade we're going to be using these modeling tiles, and this is the key for these tiles. So this might be a good thing to have memorized because we're going to work with this quite a bit this unit. So this represents a 1, this represents an x, this represents -1, and this represents a -x. So let me show you an example of how we would use these. So it says to model the expression 5x plus -3x minus 6 plus 4 with tiles. So first of all, I need to model 5x. So that means I need 5 positive x's. 3, 4, 5. And then I need to combine that with -3x's. So that means the -x, that means I need 3 of these. This represents -3x. Okay, next I have a -6. So here's my negative tile, so I need 6 of these -1s. 4, 5, 6, and then finally a +4. So I need 4 +1 tiles. Okay, so this set right here represents the expression 5x minus 3x minus 6 plus 4. Okay, so that's how I would use tiles to model the expression. Now, the next thing that's going to help us with these tiles is we're going to be finding zero pairs. Now, a zero pair is just any combination that yields a value of 0. So, for example, if I combine a +1 tile and a -1 tile, those two things combine to be 0. So this is called a zero pair. Then also, if I take an x tile and a -x tile, these two things combine to be 0 also. So this is considered a zero pair as well. So we're going to be using zero pairs to help us simplify expressions. And we'll talk more about that in a little bit. But first of all, let's go back to our example with this expression and let's see if we can find any zero pairs. Okay, so I'm going to circle the ones that I see. There's an x and a -x, so that equals 0. Here's an x and a -x, so those two things combine to be 0. And here's another x and a -x. Those two things combine to be 0 as well. Okay, let's move on to the 1 tiles and the -1 tiles. So -1 and 1 combine to be 0. These combine to be 0. Hopefully you can see the pattern here. So look at all those things that combine to be 0. And then all I'm left with is 2 x's here and -2 tiles right here. So I took this expression here, and after getting rid of the 0 pairs, I found that the expression was equal to 2x minus 2. Okay, and so this is what it means when we say to simplify an expression or an equation. It means we want to minimize the number of symbols necessary to understand the expression. And we do that by finding zero pairs with tiles. Okay, so notice this was our original expression. And then after we got rid of zero pairs, we found that this was also the expression. These two expressions are equal to each other because after finding zero pairs, we found that 2x minus 2 was the same as this expression here. So that is your first introduction to expressions.